Hello, welcome again. Geometry section 4.3 today. Congruent triangles. Congruent corresponding angles / sides. Alright, two figures are congruent when their corresponding sides and corresponding angles are congruent. What does that mean? If we take a look at our picture here, we have two triangles. Alright, they have both those triangles are congruent. Triangle ABC is congruent to triangle PQR. And the reason why that it is because each one of the corresponding angles is congruent. So for instance, angle A and angle P are congruent. They're in corresponding spots, just like on corresponding angles from the lines and transversals. Angle R and angle C are in corresponding spots and are congruent, and angle B and angle Q are in corresponding spots and congruent. Not only are their corresponding angles congruent, but also their corresponding sides are congruent. Here we have AB and PQ, so we have AB, PQ being congruent, and down the line BC and QR and CA and RP. So all of the corresponding angles and corresponding sides are congruent, and that means that two triangles or two figures, not two triangles, two figures more powerfully, are congruent. There is more than one way to write a congruence statement, but you must list the corresponding angles in the same order. So the corresponding statement here is what we're addressing. Triangle ABC and PQR. Order is very important. Please note that it is A and P are in the same spot because A and P are congruent to each other. Same thing with B and Q and C and R. Each one of those has to be across from the other in the congruent statement, otherwise it does not show congruency properly. So you could change it and write CBA is congruent to, but then you'd have to make sure to state that RQP. So triangle CBA would be congruent to triangle or figure RQP. Alright, and you have to have the angles match up when writing the congruent statement. Alright, and here's another picture of that. And again, you can see the color coordination. A and H are in red down here in the congruent statement. B and J are congruent to each other in blue, and C and K are in green. Again, you can write it in different ways, but you have to have corresponding angles in the same spot with one another. Alright, naming congruent parts. Write a congruence statement for the triangles below. Identify all pairs of congruent parts. We have ABC congruent to ZXY. We want to write a congruency statement that talks about each one of the angles and the sides being congruent. So starting with the angles, we would list angle A congruent to angle Z, angle B congruent to angle X, and angle C congruent to angle Y. Finishing up the congruency statement, we then would have the corresponding sides, and we would state that side XY is congruent to BC, side YZ is congruent to AC, and side XZ is congruent to AB. On your test, you're going to be given a figure and be asked to write the congruency statement given that two figures are congruent, and it simply means to write down the congruent angles and the congruent sides. And as long as you can do that kind of like bookkeeping or record keeping task, you should be fine. Alright, continue with that again. Identifying corresponding congruent parts. Show that the polygons are congruent by identifying all of the congruent corresponding parts. Then write a congruent statement. The angles. We know that they're congruent, so therefore we know that A and R are congruent. Angle B and angle T are congruent. Angle C and angle P are congruent. Angle D and angle S are congruent. And angle E and angle Q are congruent. With the sides, AB is congruent to RT, BC is congruent to TP, CD is congruent to PS, DE is congruent to SQ, and EA is congruent to QR. Writing this all up, keeping it in order, we can show that the two polygons are congruent by writing that polygon ABCDE is congruent to RTPSQ. please note that just because this first part is in alphabetical order does not mean the second part will be in alphabetical order. You have to go with the angles. That's one thing that students will get wrong on their test. They'll just put the letters in alphabetical order thinking that it is the correct way to go. Alright, third angle theorem. Third angle theorem states, if two angles of one triangle are congruent to two angles of another triangle, then the third angles are also congruent. Figure shows if angle A is congruent to angle D, angle B is congruent to angle E, then angle C is congruent to angle F. So we have here in the picture angle A and angle D being congruent, and angle B and angle E being congruent. We know then from this theorem that C and F are also congruent. We can kind of think this intuitively, as we know that if two of the three angles are congruent to each other and the triangles add up to 180 degrees, then the last angles have to equal the same number, because you can only get 180 degrees one way given two values. We're going to prove this later on to show it in all cases, but intuitively it should make sense. Alright, properties of congruent triangles. We do know that things hold true through several different avenues. We had the reflexive property of congruent triangles here, just like we had the reflexive property of angles and the reflexive property of segments. So we have the reflexive property, triangle ABC is congruent to triangle ABC. We have the symmetric property of congruent triangles, that if a triangle ABC is congruent to triangle DEF, then triangle DEF is congruent to triangle ABC. And lastly, we have the transitive property of congruent triangles, which states that if triangle ABC is congruent to triangle DEF and DEF is congruent to triangle HIJ, then triangle ABC is congruent to HIJ. The reflexive, the symmetric, and the transitive property are holding true in this avenue as they did in the past. Okay, and here is a write-up again of both of those from the book design. But basically it's the same information. Alright, proving the third angle theorem. Given that A and D are congruent and B and E are congruent, prove that angle C and angle F are congruent. This will be a proof that will end up on our exam later on in some fashion. Alright, starting with the given. A and D are congruent, B and E are congruent, and that's all we have to work with. Alright, knowing what we know, if angles are congruent, okay, we know that angles are equal. Okay, congruency implies equality, so therefore if the angles are congruent, they're equal to each other by the definition of congruent angles. Alright, now that we have that out of the way, what we have is we have triangles, and we're trying to show that triangles, that angles within a triangle are congruent. We might be able to show something that we know about triangles. We know that if we have triangle ABC, that the angles A, B, and C add up to 180 degrees. So therefore, we know ABC is equal to 180 degrees by just the triangle sum theorem. We just proved it in the previous section here. So if we know that ABC equals 180, we can say the same thing about triangle DEF, that the measure of angle D plus E plus F is equal to 180 degrees by the same reason. Okay. So we've given a statement about the triangle sum theorem. We notice that we have 180 here and 180 here. So if we want, we could substitute those values in and make one long congruency statement, which then would state that the measure of angle A plus measure of angle B plus C is equal to the measure of angle D plus E plus F. Substitution. If I notice from before that angle A and angle D were the same, and angle B and angle E were the same, then I would have no problem canceling out A and D and B and E from my equation. And that's what I'm going to do. Measure of angle C is equal to the measure of angle F by the subtraction property, subtracting off values that I know that are the same. And once values are equal to each other, they are congruent to each other. So therefore, angle C is congruent to angle F by the definition of congruent angles. Thus, the third angle theorem is proven. Alright, now that we've proven it true, let's use it. Find the value of x using the third angle theorem. Okay. Okay, we know that the angles are congruent, so we know that this angle D has to be the same as A, so therefore 4x plus 15 would be in for A. And I know that triangles add up to 180 degrees, so I have no problem taking A plus C plus B and setting it equals 180 degrees. And I can solve then for x. Using that logic here, we have the measure of angle A equaling 71, which is 4x plus 15. And solving all the way down, we have x is equal to 14. Alright. We know those values are the same. We have using the triangle sum theorem, and then now using the third angle theorem. Alright, determining triangle congruency. Decide whether the triangles are congruent. Justify your reasoning. Is triangle EFG congruent to triangle GHJ? Remember, what does it mean to be congruent? It means that all the corresponding angles and all the corresponding sides are congruent. We have all the corresponding sides, it looks like, are congruent, as EF and HJ are congruent, and EG and GH and FG and GJ. We also have vertical angles here in the middle, so therefore these two angles are congruent. We have 58 and 58, those two angles are congruent. And then by the third angle theorem, we would then say, seeing as how all the other angles are congruent, that E and J would also be congruent. So therefore we would say that these two triangles are congruent. Writing that up says that from the diagram all corresponding sides are congruent, and that F and H are congruent, the ones that were given to us. We know that EGF and HGJ are congruent because of vertical angles. We know that E and J are congruent because of the third angle theorem. So therefore, since all of the corresponding sides and angles are congruent, we can state that triangle EFG is congruent to triangle HJG. Okay. Again, having the matchup with our congruent angles. Alright, using property of congruent figures, in the diagram we have ABC is congruent to KJHL. We want to find two things, find the value of X and find the value of Y. Well, what we need to do is we need to at least rotate the figure so we have a common ground, or take a look at it from the outside and kind of just piece together what we do know. If we want to start with X, okay, we do know that on the exterior that the figure has to be the same. So we have JK and AB being congruent, which means they're equal to each other. So therefore, I can set 4x minus 3 equal to 9. Okay, I can add 3 to both sides and then divide by 4, giving me my x value of 3. Looking further than at Y, I have that in the spot of H. Okay, and H is in the same spot as C, as given the congruency statement. So therefore 5y minus 12 is equal to 113. I'd add 12 to both sides and divide by 5, so y is equal to 25. So using those congruent figure principles, we can solve for variables as well. Alright, same idea here in the diagram. Triangle ITP is congruent to NGO. Find the values of X and Y. We have G and T being in the same spot, so therefore here and here are congruent. So GN is congruent to TI, so 7.5 is equal to X minus 2Y. And we don't have two variables there, so we need to find the y value first, and O and P are in the same spot, so therefore 6y minus 14 and 40 are equal to each other, and I can solve for y first. Once I have that y, I can plug it back in and solve for the x value. Well, let's do that. We have O and P congruent, 6y minus 14 equal to 40, add 14, 6y is equal to 54, and y is equal to 9. Once y is equal to 9, I can plug that back in up top. And I know then that x minus the 2y, or 2 times 9, is equal to 7.5. So x minus 18 is 7.5, and x is equal to 25.5. Final answer. x is equal to 25.5, y is equal to 9. Alright, in the diagram, triangle FHJ is congruent to HFG. Find the values of x and y. So the same type of situation here. We know that we have FHJ, so F to H to J is congruent to H to F, H to F to G in that order. So we know that J and G are congruent. We know that the interior here and this one, those are going to be congruent angles. So that helps us out with the setting equal to each other. We know that 35 is equal to 6x plus 8. Subtract 8 on both sides. We have 27 is equal to 6x. And divide by 6, we have x is equal to 27 over 6, which is equal to 9 over 2, which is equal to 4.5, which takes care of B and C, leaving us with the deciding factor for the two sides, 2y minus 3 and 2.5. So we have 2y minus 3 is equal to 2.5, add 3, 2y is equal to 5.5, which means us to divide by 2 on both sides, y is equal to 2.75, or A. Final answer, A. Alright, next problem. Okay, we're going to try a proof. Proving triangle is congruent. Given L is congruent to P, LM is congruent to PO, LN is congruent to PN, and MN is congruent to OP, prove that triangle LMN is congruent to triangle PON. First thing to do, as we know with any proof, is to write the given. I won't restate that. But remember, the idea is to prove two triangles congruent. To have congruent triangles, we need to make sure that all of the corresponding sides and corresponding angles are congruent. And if we look at our figure, and this is where figures really help us out with these proofs, we can kind of prove what's left over. I notice that here in the middle we have the bow tie, which means we have vertical angles, so L and M and angle P and O are congruent by vertical angles. And if we know that two of the three angles of one triangle are congruent to two of the three angles of the other triangle, then we do know that our leftover ones, angle M here and angle O, have to be congruent by the third angle theorem. And if we have now three sides and three angles congruent, we know that triangle LMN and triangle PON then are congruent by the definition of congruent triangles, right? That's what it means to be a congruent triangle. If all of your corresponding sides and angles are congruent, then you are a congruent triangle. Alright, let's take that and apply it to a little more difficult proof here. Proving two triangles congruent, given that MN is congruent to QP and MN is parallel to PQ, also given that O is the midpoint of MQ and PN, prove that triangle MNO is congruent to triangle QPO. Now there's nothing listed for us on this picture, so what we're going to do is we're going to mark up what we know right away. We know that MN is congruent to QP. We also know that MN is parallel to PQ, so we have MN parallel to PQ. That'll help us with angles. And we know that O is the midpoint of MQ and PN. So we know that midpoint theorem, okay, cuts things into two congruent parts. So if the O is the midpoint of MQ, that means that MO is congruent to OQ. And that also means that PO is congruent to ON as well. So without even writing anything up there, we have all three of the sides being congruent. Once we have all three of the sides congruent, we can talk about the angles. And we're trying to talk about triangle MNO. So this top triangle MNO and the bottom triangle QPO. So we're trying to prove the two blue triangles congruent. We notice the relationship around O right here. We have two vertical angles, so therefore we have angles that are congruent. And the last piece of the given information that we haven't used yet is this MN parallel to PQ. Now, what does that mean? How does that help us? Well, if we're looking at, I'll make it all red now. I'm looking at this red line MN and this red line PQ. We do have transversals that cut it. And if I just fill in one of them, going from M to P, what does the red form? It forms a Z. And when the outside parts of the Z are parallel, we have congruent angles. So therefore, the angle inside here, MNO, is congruent to QPO here. Similarly, if I form green lines, I can have a green Z. And the green Z follows the same rule, which give me angle here congruent to our angle here. That leaves me with 3 angles congruent and 3 sides congruent, which leaves us with congruent triangles. So we've solved the proof on the picture. Now all we need to do is write it up formally. Again, start off with the given. We said that the angles OMN congruent to OQP and MNO congruent to QPO by the Z, or as we formally know it as the alternate interior angles theorem. We know that angle MON and angle QOP are congruent by the vertical angles theorem. That takes care of all of our angles. And we know that MO is congruent to QO and PO is congruent to NO because of the definition of a midpoint. And with all the corresponding sides and all the corresponding angles congruent, we know that triangle MNO and triangle QPO are congruent by the definition of congruent triangles. That ends lecture for today. Problems that we're going to be looking at in class, numbers 8, 9 to 15 odds, 19 to 23 odds, and number 24. Thanks for watching.